Lesson 3, the short x of f equation. Would you please pause the video if you have not yet done the warm-ups, and do the warm-ups at this time, and then when you're ready, please come and start the video up again to see your answers. Number 1, what did we do last period? That was position versus time graphs. Number 2, find the object's displacement if it starts 3 meters to the right of the origin and finishes 8 meters to the left. The 3 meters, that is going to be your x sub I, and it's to the right of the origin, so it's going to be positive. It finishes 8 meters to the left, so the 8 is going to be our x sub f, and it's to the left of the origin, so I better remember that it is a negative. So putting that into the equation of displacement is equal to the final location minus the initial location, we get the answer of negative 11. Find the object's average velocity if it moves 91 meters to the left in 3.3 seconds. So the 3.3 seconds is the elapsed time. The 91 meters is the displacement. Since it's going to the left, I have to remember it's negative. I'm trying to find the average velocity, bar v. Using the equation, average velocity is equal to displacement over elapsed time. I get negative 91 meters for the displacement divided by 3.3 seconds, and I get negative 27.6. Number 4, a car starts at the origin. Where does it end up if it travels at 30 meters per second for 9 seconds? Elapsed time of 9. The average velocity is 30 meters per second. We're not given if it's positive or negative, if it is going to the left or to the right, and so we can make our own decision there. We can assume either way, and it's usually nice to have it as a positive. Okay, so we are just going to be looking for how far does it travel, where does it end up. So you end up just multiplying 30 times 9, and we get 270 meters. Next, we have number 5. Write in scientific notation. This here, we're going to be 5.32 times 10 to the 11th. And for letter B, 3.218 times 10 to the negative 6th. Number 6, a car starts at a point 50 meters to the right of the origin. Where does it end up if it travels to the right at 30 meters per second for 9 seconds? Well, just looking at this information right here, we had a car a moment ago traveling at the same qualities, and it went 270 meters from the origin. So those piece of information give us 270 total distance traveled, but it started off 50 meters ahead of that. So we're going to have to add that 50 meters to the 270, and we get 320 meters to the right of the origin. The next problem is just like it, except we don't have numbers. We just have starting off at point A, traveling at a speed of b meters per second for c seconds. But let's go through the same process. Going at a certain speed for a certain time, we find the distance traveled then to be multiplying those things together, just like we multiplied the 30 times 9 up there. Instead of 30 times 9, I have b times c. And then instead of having a head start of 50 meters that I added to the front, I have the head start of just a generic a meters. But I'm still going to add that to the front. And so I get a plus bc as my answer. Today's goal, today's purpose, is to find the final location of an object that's moving at a steady speed. And we're going to be using slightly different equations. The relevance, to be able to predict the final location of items used in planning trips, motorcycle jumps, artillery shots, all sorts of motions. This ability to predict the future is what made me really interested in physics oh so long ago. When given initial conditions, you'll be able to predict where something will be after a period of time. You will see how well you've learned the material after you do homework B, and we'll have a quiz tomorrow. Next page. Let me zoom in here a little bit. Write the average velocity equation and replace the displacement with the definition. So the velocity equation, average velocity, is this thing right here. Average velocity is bar v, displacement delta x, elapsed time delta t. And then I'm going to add to that, or include into that, the displacement equals final location minus initial location. I'm going to put this value, which is equal to the displacement, in for the displacement in the first equation. And so what happens is I still have the bar v, still have the equal sign, but on the top, instead of the triangle x, I have the x sub f minus x sub 1 that the delta x is equal to. And on the bottom, I still have the delta t. So that's a new equation that we can use. We use this when we want to know the velocity, and you're given the beginning and ending spots. In our previous equation, we had to be given what the total displacement was. So this is a little bit fine-tuning. Next, number 2. Rewrite this new equation and get the final location by itself on the left. So we're looking for x sub f to be by itself on the left side. So going back to our other equation here, I want to get this x sub f by itself. So I'm going to multiply both sides by delta t. When I do that, I get average velocity times the elapsed time is equal to the final location minus the initial location. I'm going to add initial location to both sides, and I get this. And now I'm going to flip-flop everything. I'm going to move the final location to the left, and I'm going to move all of this stuff to the right and reorder it. And so we get this. X sub f, the final location, is equal to the initial location plus the average velocity times the elapsed time. We use this equation when you want to find the final location of an object. So let's use these equations to solve a couple problems. Darryl Green, one of the fastest football players, started on the 5-yard line. He ran towards the midfield at an average velocity of 9.13 yards per second for 4.4 seconds. Where did he finish? So we're first going to draw a picture of what we know. So I'm going to have the origin back here at the touchdown line, the 0-yard line, so to speak. And he starts off at the 5-yard line. That's the x sub I. He runs towards midfield with an average velocity of 9.13 yards per second. And the time for that is 4.4 seconds. That's all that we know. Then we have what we want to know, the final location, x sub f. Before I go on to my choosing of the raw equation, I want to make sure that all of my units are compatible. So here I have a unit of yards, and there I have yards. So those match. I don't have meters per second up here, it's yards per second. So the yards up here matches the yards there. That's good. My elapsed time is in seconds, and up here I have seconds. So those are compatible. That works. If I had yards per minute and the elapsed time was in seconds, then I'd have to do some conversions to make sure that everything had seconds in it. But everything right now is compatible. So I find the equation that gives me the x sub f. I have two equations that have x sub f. I have this one up here, and then I have this one. Either one would work, but this one here is going to be the easiest because it has the x sub f already all by itself. So we'll have to do less algebra by using that equation. So now that I've chosen my equation, I substitute in the numbers. So the initial location we said was right here, 5. Now if you want to put in the 5 yards, you can. It says here with units, but I'm going to be more lax nowadays and say as long as you have checked your units up here to make sure that they are all compatible, then you don't have to have your units down here in your substitutions. Okay, so we substitute in for the initial location. The average velocity is 9.13, and the elapsed time is 4.4 seconds. You first do the multiplication, and then you add, and you get 45.2 yards. Once you have the number, you just have to look to see what kind of measurement you're looking for. You have a location, and locations are measured in a somewhat kind of a distance away from the origin. So we put in the yards to match the yards up here. Number 4. Your teacher is making a flying homemade airplane. He starts off 1 kilometer north of his home and flies south. After 60 seconds of flight, he's located 200 meters south of his home. What was his average velocity? So the picture is going to look like this. Here we have the home, and I'm pretending that this paper is a map. So the location of the airplane is initially on the north side of the house, which is on the top side, and the initial location 1 kilometer. The elapsed time of this motion is 60 seconds, and then the final location is given to us as 200 meters. Before I go on to my equation, I have to check my signs and my units. You should see here that I have kilometers up there, and I have plain old meters there. So I got to do a conversion, and I'm going to make this 1,000 meters. I could have made this meters into kilometers, but the standard idea in most of physics is to have the distances in meters. Also, I need to have positives and negatives. I need to decide, excuse me, where the origin is. Since this kilometer and this 200 meters is measured relative to the house, I'm going to make the house the origin. And traditionally, up, whether it be up on a map or up into the air, up is positive. So I'm going to have the initial location is a positive 1,000 meters. The final location is going to be below that, negative 200 meters. So now I have compatible units, and I've done my signs. So now I can move on to the raw equation. In this case, I am looking for the velocity. So I would prefer to use the equation that has the velocity already by itself. I could use the other equation, the one that we just used in example 3, but there I'd have to do some more algebra, and that's no fun. So use this one. Put in my numbers, negative 200 for the final location, minus the positive 1,000 meters for the initial, divided by the elapsed time of 60. Do your math correctly, and I hope you get negative 20 meters per second. Important to remember. Last note here. Homework problems may describe the motion of objects as a speed of 23 meters per second, or moving at a rate of 2 miles per hour, or something is traveling at 5 inches per hour. These are not using the word velocity. They're using other terms. And so we don't know if these numbers should be positive or negative. You have to decide by the context of the question whether to put this as a positive or a negative 2 miles per hour, a positive or a negative 5 inches per hour. If the story problem says it has a velocity of 5 inches per hour, then the positive 5 would be implied there. Any other word besides velocity, you have to decide yourself by the context. Number 5, the last part of the notes. How would you rewrite this equation to reflect vertical motion? Well, we'd have the average velocity is equal to the final y location, f, y sub f, minus y sub I. Or the other equation, y sub f equals y sub I plus average velocity times t. Please turn the page. Read those steps on your own. Turn the page, and we have a wrap-up sheet. Would you please tear out this page from your packet and answer all the questions 1 through 11, put your name at the top, and turn it in before you leave. That's it. Thank you very much.